Hello everyone. In this video, I want to share a personal insight on the intuitive understanding of the GM formula. This is my own understanding, so please correct me if there are any errors. The GM formula is shown here. This formula is crucial for understanding the operating mechanism of OECTs. The mathematical derivation is provided in this paper, but it may not be enough for us to establish an essential and intuitive understanding of this formula. Now, let's understand this formula intuitively. Let's reorganize the formula and divide it into two parts. First, let's focus on part 1, starting with carrier mobility. What is the essence of carrier mobility? Carrier mobility is defined as carrier velocity divided by field strength, meaning the carrier velocity per unit field strength. So, how to understand mu equals 1? If mu equals 1, it means when placed a carrier in a unit electric field, the carrier velocity will be 1. What about mu equals 2? If mu equals 2, when placed in a unit electric field, the carrier velocity will be 2. For any mu, it means when placed a carrier in a unit electric field, the carrier velocity will be mu. Generally, if you put a carrier in a field strength which doesn't equals 1, the carrier velocity will equals mu times the field strength. Okay, keep this formula in mind. Using P dot PSS as an example, its length, width, and height are L, W, and T, respectively. If we apply a VD voltage on the source and drain, the carrier velocity will be mu times E. Here, E equals VD divided by L, so the carrier velocity equals mu times VD divided by L. This is the first part of the GM formula. Now, let's move to part 2. In a semiconductor, there are carriers in it, and cation in electrolyte. If we apply Vg, cation will be injected into the semiconductor, reducing the same amount of carriers. That is to say, ions injection equals carriers reduced. So, how to quantitatively describe the effect of gate voltage on ion injection? The answer is capacitance. It equals delta Q divided by delta Vg, and gate voltage corresponds to the delta Vg. The ion injection corresponds to delta Q. In addition, the capacitance depends on the material and the volume. If we want to eliminate the influence of volume, then divide the capacitance by the volume. This is the C star in the GM formula. For this formula, it means per unit volume, per unit gate voltage, the variation in charge quantity. Then how to understand C star equals 1? Still, the semiconductor mentioned before, we can divide it into many unit volume cube. And we choose one cube. For this cube, we give it a 1 volt change on gate voltage. And then there will be 1 coulomb cations injected into semiconductor, following 1 coulomb carrier reduced. So the change of the charge equals 1. What about C star equals 2? It's similar, but the change of the charge equals 2. For any C star, it means the change of the charge equals C star. The above is for the unit cube. If we cut a slice from the entire semiconductor, and then I give it 1 volt change of Vg, then the amount of change in charge is multiplied by Wt on the basis of C star. This is the second part of GM formula, and its physical meaning is the amount of change in the amount of electric charge per unit length. Okay, let's review the first part just now, which is the velocity of carrier. They are measured in coulomb per meter and meters per second, and when they are multiplied together, that's current. So the change in current in the semiconductor is delta Q times V. The amount of current change caused by a 1 volt change in gate voltage is exactly the definition of transconductance. Okay, that's all. Thanks for watching. If you enjoyed this video, don't forget to like and subscribe. See you in the next one.